He's a musician. No one. Hello.
Good morning, everyone.
Yes, teacher, we can hear you. Good morning.
I want to welcome you for this lesson. I want us to start from here. Those on the call, as we were put forward by one of the administrators, one of the communications was that you're supposed to be able to put up on the chat our names clearly and the contacts. As we are going to move on, I will encourage us to put off our videos. This will help us in saving some data. And then moment where I pose a question and require you to contribute, I think you'll have to put up your hand. I want to welcome everyone for these free lessons, which we still continue to have, courtesy of Yaaka Digital Network and the Educare. We are still moving on with these lessons up to the 10th of this month. My name is Yandu Amos, and my contact is in there. Hello, members. I want someone to remind us of what we did look at last time. Anyone who could remind us of what we did look at last time? Those who are present for
about.
We learned about work. Stella, from Stella there, Stella is saying we learned about work. Good. Today we're looking at energy. What is energy? What is energy? What is energy? Hamira.
Energy is the ability to do work.
Energy is the ability to do work. Good. Hope, do you have a different view? Is it the same?
It's the same.
It's the same. Queen, what do you say? So we're saying energy is defined as the ability to do work. So what is the SI unit of work? What was the SI unit of work as we looked at? Still see Amira's hand up. Hope is also now trying to put up her hand. Hope, what do you say? What is the SI unit of
Joules?
Joules?
Joules.
Yes, SI unit of energy is also joules, because the work that is done is usually converted to energy. So it is because of that that energy and work have the same SI unit. So the SI unit of energy is also joule. I just commented about how we can be able to write the joule in words and then the joule as a simple. I did say that in writing out this, when you are writing joule in words, so it starts with small j. And I really emphasized on how we can be able to write this capital J. You know, the computer sometimes also tries to misdirect us. So the J has the other parts, the other upper part. So it is like that. So the SI unit of energy is also joule. We have other units of energy. You can be able to measure energy in other units. And these other units include the kilojoule and the megajoule. How many joules are there in 1 kilojoule? How many joules are there in 1 kilojoule? You know, kilojoule is a bigger unit. There are 1,000 joules, 1,000 joules, correct? What about in 1 megajoule? How many joules are there?
1 million.
1 million. So in 1 megajoule, there are 1 million joules. Now, if you can now use the two relationship, the two relations between kilojoule and joule, and that between megajoule and joule. How many kilojoules are there in 1 megajoule? Let's say in 1 kilojoule is equals to 1,000 joules, then 1 megajoule is equals to 1 million joules. Now, having known this, how many joules are now there in 1 megajoule? Okay, look, can you try? Mm-hmm.
1,000.
1,000. Very good. We have 1,000 kilojoules in 1 megajoule. Now these relationships are here. 1 kilojoule is equals to 1,000 joules. Then 1 megajoule is equals to 1,000 kilojoules. And then 1 megajoule is equal to 1 million. We have 1 million joule there. So you will be able to use this given relationship here between the units in calculations. These are mainly applied in calculations. You find in calculations, you'll be required to make use of this. Now, energy appears to be taking different forms. We have forms of energy. Can we briefly mention the forms of energy that you know? The forms of energy that we know. We are going to just have a simple hope you're starting straight away.
Heat energy.
Heat energy, very good. Dorish?
Light energy.
Light energy, correct. Scovia?
Kinetic energy.
Kinetic energy, correct. And
Mechanical energy. Solar energy.
someone is saying solar energy. Someone is saying mechanical energy, correct. All those ones are forms of energy.
And sound energy.
Sound energy.
Nuclear.
Nuclear energy, correct.
Electric energy.
Electrical energy.
Chemical
that is being
energy.
said by, I think, chemical energy from Stella there. Stella is saying chemical energy. Presmia, is there one left that you want us to know? Those are some of the forms, the various forms of energy. So you find energy exists in any of those forms. Energy exists in any of those forms, or it takes any of those forms. So we can be looking at this, how important they are, maybe one after the other. See, the first form of energy that we have is the light energy. I think commonly we find we we are able to have this around us. And currently, even where we are, I know there's just light next to us, or where we are right now, we have light in plenty. Am I right? Where we are right now, there's a lot of light where we are. So it is actually the form of energy that enables us to see. So why you are clearly able to see right now during the day is because you have sufficient energy, which is in form of light. It enables us to see. I think someone did mention for us heat energy as one of the forms of energy. What do we use heat energy for? Who's going to help us and give us an answer here? What do you use heat energy for? If I can just go to the chart, electrical potential energy, that Michelle is saying electrical energy. We have light energy, geothermal energy, correct also, mechanical energy, physical energy. Someone is saying for cooking, heat energy is for cooking, good. Another person is saying cooking, Zarifa is saying cooking. Another, in which way do you use the heat energy?
Ironing clothes.
So heat energy is for
Boiling
ironing our.
water. Boiling.
It is for. What about chemical energy? Just we have this chemical energy that we receive from the food substances that we are able to eat, or from the chemical cells. We obtain this chemical energy from the foods that we eat or from the cells, and then they are used to generate energy. Chemical energy, these ones are mostly we prefer using them to generate energy. You have even the cells that give us this form of energy. So what we have for heat energy is the energy that we actually get from the hot substances, and then we use sort of them for doing a couple of work, including cooking. Solar energy. What is the major source of solar energy?
For light.
Solar energy, someone saying for light. Doris.
The sun.
Doris, what are you? From the sun. Good. Solar energy is received from the sun. And what do we use it for?
For providing light.
Providing light. See, we receive this from the hot sun. The solar energy is received from the hot sun, and it helps actually plants in the manufacture of chlorophyll. And then you know how important this chlorophyll is for the plants. What is the use of the chlorophyll for the plants? If we can get to biology a bit here.
Traps
How
sunlight.
important? Good. So it traps that now, sunlight. And then you find the whole thing is used by the plants in the process of them manufacturing their food. But we receive this solar energy actually from the hot sun. And then you know how beneficial the energy from the sun is to us. So we can even use it to this solar energy from the sun can be trapped by the solar panels, and then later we use it to provide for us some energy in the form of light. You can even be used for cooking, where we convert now that energy into heat and so on. So that is how important we have, how important that energy from the solar is, where the key source of solar energy is what? The sun. We have electrical energy. What is that you know about electrical energy as far as it is concerned? Hope?
Is the form of energy due to the flow of charge.
Is the form of energy that is in form of flow of charges. That's what Hope is trying to give us there. Stella?
It is produced by energy transfers at power stations and battery.
Energy from power stations and the batteries. So in many cases, we use it for lighting in our rooms. Why lighting in our homes? So you find this electrical energy has so many importances. We use it for lighting our rooms. What else? What else do you use the electrical energy for? He said there are so many ways you can be able to put this energy into use.
It is used for running machines in industry.
When you go to the industries, you find there should be some big source of electrical energy that actually runs the machines. So we use it for running machines. So we use that in that way. We also do have, someone just did mention for us. Could we? Someone just mentioned for us mechanical energy, as broadly as it is, as one of the types, of energy. So mechanical energy is the form of energy that is broadly classified into two. We classify mechanical energy into two forms. The first one is what we have right there, which is kinetic energy. What is kinetic energy? What is kinetic energy? What is kinetic energy? There.
Kinetic energy is the energy possessed by a moving body.
Energy possessed by a moving body. Very good. Is there someone who has a very different answer? Do we have someone with different answer? Bonita, do you have a different answer? Okay, Vincent is from the chat saying that is the energy possessed by a moving object. Then this Bonita also say energy by a body by virtue of its motion, correct? Is the energy possessed by a body by virtue of its motion? That's from Michelle. And then we also have from Queen, energy possessed by a body by virtue of its motion. I think all the answers are just what we do have here. So it is the energy which is possessed by a body by virtue of it being on motion. So someone is saying it actually enables us in movement. This is persons who's giving us that it enables us in movement. Praise me. I see your hand is up. Praise me, your hand is up. So we have kinetic energy, that is actually the energy you get from moving objects. When an object is in a state of motion, you'll be able to obtain from it that form of energy, which is a kinetic energy. We have the next form of mechanical energy, which is potential energy. What is potential energy, or what do you understand by potential energy? Can I see hands being put up? There are some, since we started with the lesson, I don't know if we have some issues of network or what. Some people have not given me an answer, even on chat. You could be, if you have issues with your mic, you can be giving us answers from the chat. We can, for me, I can be able to read from there. Maria Trisha. What is potential energy?
Potential energy is the type of energy possessed by an object at rest.
Energy possessed by an object at rest. I want Elisha and Joel to put it in another word, another different way.
Potential energy is the energy by virtue of the object's position relative to other objects.
Energy by that a body possesses by virtue of its position. That's what someone say. That's what Alicia had been able to put us. Alicia and Joel. Someone
It's Joel, not Elisha.
Yeah, it's Joel. Oh, thanks for that correction.
Yeah.
Doris, what do you say? I see your hand is still up.
Potential energy, the energy possessed by an unmoving object.
Okay, Vincent.
Potential energy is the energy possessed by an object at rest above the ground.
An object at rest above the ground. So if I can go to the chart, from the chart we have here, from Hope, potential energy is the energy possessed by the body by virtue of its position in the gravitational force. Aquilina is saying it's energy possessed by body at rest. Player is the energy stored in forcefully interacting physical entities. Those are some of the concerns or responses from the chat. We have now simplify the answer to this. I was saying, I want Hope to read for us this.
Potential energy, this is possessed by a body by virtue of its position.
Which means when we say by virtue of its position, we are meaning that by virtue of it being at rest. When we talk of position, which means you have some specific point where you are. So basically you are at a rest. Geothermal. We have geothermal. Anyone with any idea about geothermal energy? Those who, as I said, those who can be able to respond through your audio, your microphone has a problem, you can have your concern from the chat. I'll definitely not leave you out. Bonita is saying energy obtained from hot springs. Energy obtained from hot springs. Queen is also saying obtained from hot springs. Geothermal energy is obtained from hot springs. Those are concerns that people are trying to give for me on chat as far as geothermal energy is concerned. Michelle is saying obtained from also hot springs. So this means that we know, this means that the energy that we always obtain from hot springs is called the geothermal energy. We have very good geographers around here who are currently in for this lesson. What are these hot springs, or where do we get them from? Where do you get to know about these hot springs, or where can we get hot springs? Someone in the Stella is simplifying that for us. The answer here, that is that energy which arises from the fact that it is hot deep inside the earth. Energy that arises from the fact that it is hot deep inside the earth. Someone saying the power generated from hot springs. What are these hot springs? Geographers. My good geographers, what are these hot springs? Who's putting up the hand? Can I go to, let me go to the chart and find out. Queen. Queen, what is the hot spring? Ayamba, Queen. Elizabeth. Queen, you are not talking. Praise Mayor is saying in Western Uganda where, but he has forgotten the place. Just that is saw the hot spring in Western Uganda and has forgotten. If I can also still remember my geography, I think that is true. Do we get this from mountainous areas mainly? These hot springs, I think you mainly get them from the mountainous areas. Those Queen is saying the microphone has got a problem. Yes. Aquila is saying it is true that we get them from what? Mountainous areas. Someone said Kibiro Hot Springs. Blair is saying Kibiro Hot Springs. That is one of the examples. I know one. There's one hot point in Western Uganda where you get about this. But as I said, these are energy we obtain from Maria Trisha.
I'm trying to explain the term hot springs. This is produced by the emergence of geothermal heated groundwater. Yes,
So you can see,
all.
let's say it is the term is coming there. I think that one I just don't need to say anything about it. It is actually emergence of hot ground water, and then from this we get what we call the geothermal energy. So the energy is obtained from there. It serves for us a lot of purposes. And Buranga hot spring is one of the hot springs that Blair is trying to give us, and you can get that from Western Uganda. So we have a couple of examples of these points where you can be able to get these hot springs, and then obviously where we can be able to get that energy. So that energy is so important. It is used for generating, or it can be converted to another form of energy, and then we make use of it. And then we have sound energy. What is sound? Or Dorish, how important is sound energy? Or what is it?
Sound energy is the energy that helps us to hear.
Sound energy helps us to hear. Very simple. That is one. Any other? Hope? Idea leave. Well, sound
type of energy produced by vibrating objects.
It is produced from vibrating objects, and it enables us to hear. So we are able to hear because of this form of energy called sound energy. So we have those other forms of energy like even the nuclear energy. We did talk, we have not been able to get here, but this nuclear energy, where do we get them from? What is the source of this nuclear energy? Anyone who is aware of the source of nuclear energy? where we get it from? Those who always like watching movies, you find, someone says from nuclear power plants, correct? From nuclear power plants. So you find during those who watch movies during the attacks, that leads to the unleashing of bombs. When these bombs blast, the kind of energy that we obtain from these bombs is called the nuclear energy. So the nuclear energy is a very important form of energy. This energy is not only very destructive in a way you see it there. That energy can be converted to another form of energy, and then we can be able to make put it into another use. So if I get to the comment section, I mean chat section, you're saying, Praise is saying, is the energy formed by means of vibration, that is sound, through the bursting of bombs. This is for, I think, nuclear energy. So now let's look at the potential energy here. In potential energy, with potential energy, you see, we have that when a body of a mass, we can say when a body of mass, M is raised through a certain height above the ground, or it is released from a certain height, which is h. Its gravitational potential energy can be calculated. We can be able to calculate this energy when we know the body's mass, and then we know the height to which it is being raised up through the ground, from the ground, or it is being lowered to or released to. So now, which means our potential energy can be calculated by multiplying the mass of that body by the gravitational force, or the acceleration due to gravity, and then by the height. So you can see that from that body, I mean, this body may be raised to a certain height, or it is allowed to, or released to fall from a certain height. That height has to be noted, and the height is from the ground. You take note of that height from the ground, but you usually know that the mass of the body actually remains it remains constant. You can be able to measure the mass of the body. So you have the instruments that you can use to measure the mass of the body. So when you know the mass and the gravitational force full of, the acceleration due to gravity, G, the value is always constant. So you can be able to substitute after you have measured the height from which this body has been released or it has been thrown up. So from that, we can be able to have our calculations. So you might be asked a question where they'll say, for instance, an orange of mass 500 grams drops from the tree 10 meters high, and then find the potential energy of the orange. Find the potential energy of the orange. So how do you start going on with that? How do you start going on there? How do you answer that question?
We first
Who's talking? Hope. Hope. What do you first? What is the first thing? I said in calculations there are how many steps?
The grams into kilograms.
Someone saying we change the grams into kilograms. Yeah. We change the grams to kilogram. That is what she's saying, which is true. We needed to change that. We shall have to change that. Any other? We know potential energy is given by that formula. Potential energy is given by mgh. Is it okay? Potential energy is given by mgh, where m is the mass, g is the acceleration due to gravity, and h is the height to which this object has been raised, or to which the object was released or was allowed to fall. So the mass of the body is 500 grams. So we change it, we shall change it to what? This is now the step of substitution. In substitution, as we are substituting, you can see we have changed now the 500 grams to kilograms, because we say in 1 kilogram, how many grams are there?
1,000.
1,000 grams. So that is why now we are dividing. We are dividing 500 grams by 1,000 because between mass and kilogram, mass is a smaller unit. We are converting a smaller unit to a bigger unit, so we shall be dividing. Then the 10 that you see right here, this is the value of acceleration due to gravity. Then this other one is the height of the height through which the orange drops. So when you multiply this out, what do you get? What will be the answer?
50 joules.
You get it? You'll be getting you'll be getting 50 joules. You'll be getting 50 joules. So that will give us the answer. Next, we have a question where we're required to a box of mass 50 gram requires 1,000 joules of energy to lift it. To what height will it reach? Can we try that out? Box of mass 50 kilogram requires 1,000 joule of energy to lift it. To what height will it reach? Who has already tried and found out the answer? We're saying 2 meters. Quilla is saying 2 meters. Can see. Carlo is saying 2 meters. Bonita 2 meters. I think all of us we have got actually
2 meters.
2 meters.
Yes.
So you see, in the first step, we had to what? Put the formula. In the second step, we had to substitute. After substituting, we came up with the answer with the unit. So the answer is with the unit. So you can see from there are 3 steps when it comes to calculations in physics. First one is the formula, substitution. Last one is answer. Doris, is there a different concern? I'm seeing your hand is up. Oh, you're trying to mention for us. I mean, you're trying to give us the answer. Meanwhile, if we're to have that calculation involving kinetic energy, you may have maybe a body which has a certain mass, and then it moves with a speed, maybe or velocity v. Speed is a scalar quantity, meanwhile velocity is the vector quantity, but these are the same quantities. they are the same quantities. So if the mass of the body is m and the velocity or the speed is v, we can be able to calculate the kinetic energy. This kinetic energy is calculated from the formula half mv squared. And we did say that this is the energy a body has because of it being on motion. So when a body is on motion, can be able to calculate its energy, the energy it has, and the type of energy that you'll be calculating from that body is called the kinetic energy. Now let us have this example where you're supposed to calculate the kinetic energy of a ball of mass 300 grams, which is also moving at 4 meters per second. What is the mass of the body? What is the mass? The mass of the body is, Hope.
300 divided by 1,000.
300 divided by 1,000. Someone will be asking, why are always dividing? See, we said that as we're going to have our calculation of the final answer in Joule, it is required that we said this, as we calculate that, it is required that the mass has to be in its SI unit, and the SI unit of mass is kilograms. The other quantity will also have to be in its SI unit. So in this case, it is actually what? The velocity here. So it has to be in its SI unit. So you get 300 grams. When you convert to kilograms, you have 300 out of 1,000. So you multiply that by the square of the velocity. The square of the velocity, you see, velocity here is what? 4 meters per second. So when you square it, you say it is 4 squared. So sometimes they will not say the body is moving like here. They have not said the body is moving with a velocity of this. What now helps you to know that this is velocity is what? The unit. It is important in physics to know the units of the physical quantities, because sometimes in the calculations, the units will be so important. So when you calculate that out and you simplify, what will be the answer? What answer do you get? 4 squared will give you 16. Half of 16 is 8. 8 times 0.3. Do you get 2.4?
2.4 joules.
2.4. Get 2.4. Okay. Very good. You get 2.4 joules. Yeah, as we close, we have now looked at how we can be able to calculate those two types of energy, those two forms of energy, kinetic energy and potential energy from their equations. So this is what we have not looked at, but it is what will take us to the next concept. I want you to state with relevant equations the work energy theorem. How is, we said, we just said something that when some work is done, at some time the work is converted to energy. So as this is done, so what are the relevant equations? I want you to state, do the relevant research, and as you do it, at the end of the day or shortly after here, you should be able to come up with the relevant equations and the work energy theorem. I thank you for listening, for the active participation, and that's where we shall have to stop for today. But however, matter of reminders is that as we are moving to soon,
do we pay for the online classes?
Well, I think we have been able to, we are having this training for both your parents as Yaaka and Educare. The team at Yaaka and Educare has been having training for both the students and for your parents. And then some of the areas that have been able to, that we're able to know about here are how we can be able to subscribe to Yaaka and how the payment for the lessons can be done. That will be after the, you can be able to enroll now. But otherwise, we have this as we continue to move the online services that we offer as Yaaka. We have 500,000 for the 1 full year subscription that you'll have. So which means when you have enrolled on Yaaka, you'll, for a class, it is for 500,000. And this includes the interaction. The one who has just put mute that mic. I'm here to explain something about here. So for your subscription here includes interaction, where you'll have class engagement like this. You'll have access to courses or even subjects on our website. There you'll be studying or even you'll be revising at your own time. You have a lot of courses or subjects which are on the website there, a lot of information there. So you'll be having access to them at your own time. We have even assignments, we have even quizzes, we have exercises, we even have some of these we refer to as the end of year exams, so that you are able to do, and then we mark and grade them there. So you do this out of the 500,000, it is done there. You do it at your own pace. It doesn't mean that maybe when the schools will reopen and then you go, you can still come back, and then even when you're there at school, you have access to internet, you can log in and continue to study, continue to do the course there. That is what we have for Yaaka. And then we also have services where you can be able to download maybe subject notes. A single subject goes for 10,000 for those ones in primary. I mean, for primary section and secondary section, it goes at 10,000. Then all the subjects in one class in a primary, you can download them at 30,000. Meanwhile, for those ones at secondary, you can download at 50,000. But now, if you cannot be able to afford this, you see, this is where we do not what? Actually, this is where we're having this kind of interaction, active interaction between the teacher and the learners, even between the learners themselves. That is among the that is inclusive in the 500,000 that you're going to. But there's the other service offered by Educare, in which we're partnership with as Yaaka, where you can subscribe. You have only learning materials there. You get to interact with the learning materials which are there on Educare. These ones include the learning notes and then videos. We also have videos. So the subscription fees is that you can be able to have 2 days free access, or else you can go for 20,000, which is for 1 month, or you go for 50,000, which is for 3 months. If you can also not go for that, you can also go for the 70,000, which is for half a year. So the last is subscription you can be able to make is for the annual one, which goes at 100,000. So those are the few things maybe I might be able to say. But after this session, I think we shall be able to share for you more on subscription on Yaaka and the Educare. I think none other than that, I want to thank you for listening and for your active participation.
Welcome, Chan.
I have a question as from chat. Someone saying, can do whatever you like. Even put someone saying, where is the assignment? Thanks. Someone say, where's the assignment? Just for the other person, you are to state with the relevant questions the work energy theorem.
Yeah, I'm right. But it can't show. How do you go to
Thank you for the participation. Let us meet next time.
Thank you.
Bye.
Thank you, teacher. Thank you.
Wait, how do you put it down? Yeah, you were using mom. No, you can't even do this. How?
You guys should be